I mean, you've seen this U-shape, right? It's everywhere you look. The path of a basketball, the curve of a satellite dish, it's a parabola. And today, we're going to zero in on its single most important point, the vertex. Let's get right into it.
Okay, so let's just jump in. With amazing graphing tools like Desmos, finding the vertex is, well, almost too easy. You just pop in the equation, and boom, the graph appears. You can literally just click on the very top or very bottom of that curve, and it tells you the vertex. It's the absolute minimum or maximum point, served up on a silver platter.
But that feels a little bit like magic, doesn't it? What's actually happening behind that click? How does the math pinpoint that one specific spot on the curve? That's what we're going to unpack. We're going to go from just seeing the answer to really understanding how to find it ourselves. So here's our game plan. First, we'll nail down what the vertex really is, then we'll look at its secret partner, symmetry. After that, we'll unveil the formula, walk through an example step by step, see why this matters in the real world, and cap it all off with a really cool shortcut.
All right, first things first. What exactly is this point that we're so focused on finding?
The vertex is, in the simplest terms, the turning point of the parabola. You know, if the U-shape opens up like a bowl, the vertex is the very bottom, the lowest point it can possibly go. And if it opens down like a hill, the vertex is the peak, the absolute highest point.
And you can see the two flavors of parabola right here. On the left, it's opening upwards, so that vertex is a minimum. On the right, it's flipped over, opening downwards, so its vertex is a maximum. Either way, the vertex is the extreme point of the whole curve.
Now, you can't really talk about the vertex without talking about its inseparable partner, the axis of symmetry. And understanding this relationship is absolutely key.
So what is this thing? Well, the axis of symmetry is this invisible vertical line that acts like a perfect mirror. It slices right through the parabola, and the curve on the left side is a perfect reflection of the curve on the right. It's what makes parabolas so beautifully symmetrical.
And here's the big aha moment. The vertex always, and I mean always, sits directly on this axis of symmetry. That is the critical insight. If you can figure out where that line is, you've already found the x-coordinate of your vertex. You're halfway there.
So the million-dollar question is, how do we find that line? Well, you're going to love this. There's a beautifully simple formula that works every single time. And here it is. For any quadratic equation written in this standard form, the formula is just x equals negative b divided by 2a. And don't let the letters scare you. The a and b are just the coefficients, the numbers in front of your x squared and x terms. This little formula is the key that unlocks the x value we need. But why does that formula even work? Well, it's actually pretty clever. As Rademacher Math puts it, that line of symmetry is always located exactly halfway between the 2 points where the parabola crosses the x-axis. So our formula, negative b over 2a, is just a super fast way to calculate that midpoint. Okay, enough theory. Let's put this all together. Let's get our hands dirty and see how this works as a simple two-step process to find the complete coordinates of the vertex. All right, let's take this equation, y equals x squared minus 4x minus 5. Step 1, we use our formula. In this case, a is 1 and b is negative 4. So x equals negative 4, watch that double negative, over 2 times 1. That just becomes 4 over 2, which is 2. Boom, that's our x-coordinate. Now, for step 2, we take that value, x equals 2, and we plug it right back into the original equation to find its y partner. So, y equals 2 squared minus 4 times 2 minus 5, which all works out to negative 9. And this is so important, I really want this to stick with you. The vertex isn't just a number, it's a location, it's a point on the graph. That means it has to be an ordered pair, an x-y coordinate, that tells you exactly where that turning point lives.
And there you have it. We put our two pieces together to get our final answer. The vertex for this parabola is the point 2, negative 9. Simple as that.
Okay, I know what you might be thinking. This is cool for a math class, but when am I ever going to use this? Well, it turns out that finding a maximum or a minimum value is at the very heart of a ton of real-world problems.
Anytime you hear a question asking for the maximum this or the minimum that, your brain should immediately think vertex. It could be finding the perfect dimensions for a garden with the most space, the ideal price for a product to make the most money, or even just figuring out the highest point a ball will reach when you throw it.
Look at this example. A farmer wants to maximize their garden area.
Well, the vertex of the function modeling that area, right there at 2800, isn't just a point on a graph. It's the answer. It tells them that a width of 20 feet will give them the biggest possible area, 800 square feet.
Or how about this one with money? A newspaper is trying to find the perfect price to charge. Again, the vertex of the revenue graph reveals that financial sweet spot. A price of $31.80 will maximize their revenue at over $2.5 million. That's a pretty valuable point to find.
All right, before we wrap up, I want to show you one more thing. It's a different way of writing the quadratic equation that makes finding the vertex, well, ridiculously easy. It's kind of a shortcut.
Check this out. On the left, we've got the standard form we've been using. We'd have to do our whole negative b over 2a calculation. But look at the right. That's the exact same equation, just rearranged into what we call vertex form. Can you spot the vertex? It's just sitting there in plain sight. It's the point 1, 3. No calculation needed at all. So this is what we call vertex form. When an equation is written like this, the vertex is simply the point h, k. You just pull the numbers right out of the equation. It's kind of like a cheat code for finding the vertex. It's fantastic when you have it.
So we'll leave you with this to chew on. We've seen two ways to find the vertex: calculating it from standard form or just reading it from vertex form. Which one do you think tells you more about how the parabola shifts and stretches? And why might you prefer one method over the other? Something to think about. Thanks for joining me.